Okay. Hello, everyone. Welcome to the digital session on the topic of effective cost and performance management for Amazon EMR. My name is Diana. I'm from Unravel, and we're joined by Unravel's resident solutions engineering guru, Chris Santiago. Before we start, just a couple quick housekeeping. If you have any questions, just pop them into the questions box. Please type them in and we'll answer them live, or if we, for some reason, can't get to them, we'll certainly email back. This webinar is available instantly on demand, so if you do have to drop off, definitely feel free to come back to this page, listen at your leisure. And lastly, just let us know what you think about these sessions by rating the webinar, and if there are any other topics that you would like to hear about. So with that, I will leave it to Chris.
Awesome. Thanks, Diana. All right, so let me go ahead and share my screen. And so I'm going to presenter mode. And Diana, can you just confirm that?
Yep.
Okay, awesome. All right, folks. So for today's topic, we will be talking about effective cost and performance management for Amazon EMR. For those who don't know me, my name is Chris Santiago. I am the Global Director of Solution Engineering over here at Unravel Data. I've been with the company for a little over 3 years. You can see my LinkedIn information if you want to connect with me, as well as my email address. Over the years, the big data journey has been interesting, to say the least. Where when I first got involved, it was very focused in on-premise Hadoop, platforms such as Cloudera and Hortonworks. We have now seen a major shift in using some more of the cloud-native big data technologies, Amazon EMR being one of the most popular. And so I've had the luxury of working with customers, big and small, starting off with their journey into migrating into a cloud-native technology such as EMR, and then as well as making sure that they're getting the most in terms of performance and reducing costs, so that way they are maximizing their ROI within their environments. And so I've seen both sides. I've seen where some of this stuff can fail, but luckily enough, I've worked with a lot of customers to really help guide and consult them to make sure that they are getting the most in terms of performance and cost and reducing cost in their environment. So what I wanted to do today is I got a couple of topics here. So if anything, what I would like for you to do when you walk away from this presentation is that you have a good idea of just common usage patterns that customers that I've seen over the years use to be very successful within their EMR deployments. Then we're going to spend some time talking about some scenarios that you got to be cognizant of that could negatively impact your EMR experience, whether that be cost overruns, whether that be just wasting time from your team of troubleshooting jobs or data pipelines, or hey, I'm not getting the performance that I was expecting. And so we'll highlight that, and then we'll tie off everything by showing you some best practices for effectively tuning your EMR clusters and environment overall for effective performance and cost. So we'll start off by talking about common usage patterns of successful EMR deployments. So like I stated earlier, worked with lots of companies, big and small, on their customer or on their data journey into the cloud. And so, a lot of things why, especially the customers that have been very successful with EMR is, they really take advantage of this simplified approach. Hadoop as a managed service, right? For the folks that maybe started their big data journey on-prem, I think you probably had spent a lot of days and maybe even weeks, setting up an environment, getting things up and configured ready, stabilizing the environment, making sure that everything is performance and uptime is, as high as possible, right? And that can become a burden, right? And so moving to a more managed Hadoop as a managed service is always, very popular driver for a lot of customers going into EMR. The other thing to keep in mind too is hey, once we're actually in EMR, to spin up a cluster, it's just as easy as just clicking on a button, and there you go. Now you've got a cluster, right? So I remember when I first started my big data journey working in Hadoop environments, sometimes that could take weeks to months, right? Procuring the hardware, doing the homework and making sure you spec things out, and then actually doing the actual configuration itself. It's a headache, right? And now we're in the days of cloud, and so now you could easily just go into a portal, or maybe you even have some configuration scripts, and you can just go ahead and just spin something up, and so now it's become just faster and easier. And so successful EMR deployments are taking full advantage of that aspect. The other thing to keep in mind too is there's a lot of folks that have been burned previously about maybe using the newest version of Spark, or maybe they wanted to use some engines like Presto, right? And in a multi-tenant big data environment, that becomes tricky because you don't want to just upgrade specific versions. Depending on the distro that you're at, that might actually be an unsupported version. And so now you actually have, you abstract the ability to have specific clusters, running specific software versions. And so, that can be very useful for maybe trying out some of maybe the newest Spark build, right? And making sure, hey, am I running into any issues? And then that can be part of your software development lifecycle process. And so leveraging all this is, it makes it very, very simple for folks that are using EMR. The other trait that I see from successful EMR deployments is they're maximizing performance. What do I mean by that? Is that right now with EMR, you've got a plethora of instance types that you can select, whether they be compute compute intensive, memory intensive, GPUs. You have a lot of instance types that are at your arsenal, and going back from the on-prem world, once you actually committed to your hardware, you're committed to it, right? And so now in this new cloud world, we can go ahead and just spin up, if I know that I'm going to be doing a lot of in-memory computation, I can go ahead and select the memory intensive workloads, and vice versa, right? Compute workloads, I know I'm going to be doing a lot of compute. And so now you can be very specific on that on the workload that you're trying to run. And so, a lot of folks are taking advantage of that and seeing a lot of performance improvement from that standpoint. The other big piece, especially for folks that have done lots of different workloads into their environments, now we can move from a multi-tenant environment into single tenant clusters. What I mean by that is, instead of us having shared resources, I can have my data science projects run into their own environment. So if they're very, very bursty, they can be bursty, and they won't, for example, affect my batch workloads that previously were running on the same cluster. And so now you were dealing with a lot of resource contention. And so splitting this out, you have the best of both worlds, where you can have, all these folks having clusters that are tuned uniquely for their workloads, using instance types that are specific to their workloads. And now you can eliminate resource contention and make sure that you have a rightly tuned environment, both from the instance types and then also having a single tenant infrastructure. Last but not least, reducing costs, right? In the cloud world, it's a bit different, especially for folks that are in the cloud world today. The biggest difference is in on-prem, you've got this, you have this upfront cost of purchasing your hardware, purchasing your software, and unless if you're adding more hardware, it's a sunk cost, right? In the cloud world, you are paying as you consume resources, right? And so you need to be cognizant of where things stand. You want to be top of mind of costs. And so folks that are doing it right, they're spinning up transient clusters only when needed. What I mean by this is that job clusters have become a very popular trend for folks that, hey, maybe I have very, very heavy batch workloads that only need to run maybe once every few hours, maybe once a day. And so it doesn't make sense to have these batch workloads run on a cluster that's running, every day, like 24/7, right? And so having the ability to spin up a cluster by just, simple configuration, let it do its job, and then spin back down, you really are saving costs because you're not paying for an always running cluster. There are times where you do need a always running cluster. Maybe it could be an interactive cluster that's dealing with interactive queries, or maybe you do need to have an environment that always is spinning up and being persistent, right? And so autoscaling is a very, very popular option for those types of clusters. And so what that means is I can have a base number of nodes and then scale up and down based on needs. So popular kind of model that I've seen is we'll spin up our clusters for peak, maximum number of nodes for business hours, and then when the off business hours are there, we can go ahead and spin down to maybe like 20% or maybe 50% of the load, right? Still keeping it up and running for the jobs that always need to continue to be running, but taking advantage of really only paying for the resources that you need. And so autoscaling becomes a very popular option for those types of clusters. Last but not least, folks that are really, reducing their costs are taking advantage of discounted instances like spot pricing, right? And so AWS specifically has spot instances, which are a very great alternative for folks that maybe have nodes that they may need to use, but it doesn't have to be a specific type of node. And so AWS does provide some discounted pricing from that standpoint. And so the bottleneck or the trademark or the trade-off here is that when if you are using something like a spot instance, you do have you do run the risk of AWS taking that away from you. So you do need to be cognizant of which nodes that you're using to take advantage of spot pricing. So scenarios which negatively impact your EMR experience. So we talked about all the good stuff. Let's talk about some of the things that we, hold on one second. Real quick recap, we talked about some successful EMR deployment patterns. But now let's talk about maybe some of the bad stuff, right? Think about the negative impacts or the scenarios which can negatively impact your EMR experience. And so, some of the things that you do need to keep in mind is, hey, jobs are going to fail. Your pipelines are going to fail, right? And so, you do have some nice tooling from within AWS itself, from within your interface. But some things to keep in mind is with these clusters that are transient, with these clusters that can go away over time, when it comes to looking at historical insights, those insights can get lost when the cluster is terminated, right? And so think of things such as logs, or maybe like how did this particular job run at a particular point in time, and maybe I'm looking for trends. That sort of stuff gets lost when the clusters get terminated, right? And those are good pieces of information to really understand what was going on with your jobs. And so something to keep in mind when you're working with clusters that can ultimately spin up and down. And so you need to be cognizant of that when you're trying to troubleshoot some of these jobs. There's also a great AWS service called CloudWatch, which I'm sure a lot of you folks are maybe already using. CloudWatch is a great general purpose observability tool for all the various AWS services, right? But when it comes to EMR, there is some good metrics that it does collect, but it may not provide that full observability for your use case. What I mean by that is, maybe I want to look at things in terms of just my overall EMR estate, and maybe I want to have a tool that's talking to me in an EMR type of language, right? So like, how are my EMR costs trending over time? How are my Spark jobs? Why are they failing? And what can I do to, better understand why my Spark job is, failing or running slow? And so those are some of the things that CloudWatch may not be able to help you out. And so, making sure that you have a good plan of, or maybe even having some, DIY tooling that you've created yourself. You want to make sure that you have everything that you need to have, essentially the full picture / observability of what's going on with your jobs and your pipeline, so you're not spinning your wheels when things do fail or miss SLAs. The other thing to keep in mind is tuning your environment performance. So we had talked about previously in terms of where your costs are going. When you are submitting jobs and you're asking for a lot of resources, you're paying for that stuff. Same thing when you're looking at picking the specific instances. If you're picking instances that are just grossly over allocated for your job or whatever you're trying to do within your cluster itself, that can have a serious, significant impact in terms of costs. And how deep are you going to understanding where those costs are going? Does the platform folks that are responsible for overall costs, do they know that their instances are only being 25% utilized, but they're paying for these beefy nodes? On the jobs itself, are we tuning our batch jobs, our Spark jobs correctly, so that way we could potentially run these jobs at like 50% less resources, but are we doing it? Are we doing best practices, right? So there's a lot of things to keep in mind when you're looking at making sure that you're not wasting resources, which obviously helps from a performance standpoint. The other thing to keep in mind too is we had talked about autoscaling. Again, great feature that EMR has, but when it comes to understanding when we should be scaling up and scaling down, you want to make sure that you're doing it in a way that's going to make sense, right? Like if you have a very important batch job that's running and you miscalculated and didn't realize that was running overnight, and you scale down, that can have some significant degradations on that particular job. And so you want to be mindful of how your workloads are trending from over time. And auto-scaling, while it's great for saving cost, you want to make sure that you have that aligned with your actual usage patterns. Finally, right-sizing your environment for cost. So lots of folks, again, going back to the overall allocation of resources for jobs. So when you're looking at your particular jobs that your end users are submitting in your clusters, how do we know that they are taking up most of the resources or less resources? How do we know that we're actually picking the right instance types as well? And so all of this stuff, and also spot instance, right? One of the things that spot instances, while it's a great added feature for saving cost, you need to be mindful of which instances that you want to use for spot. One example that I've just worked with a previous company a couple of days ago was, they were using spot instances on very critical jobs. And again, the drawback, the trade-off between with spot instances, you can get a discounted price, and you're also leveraging instances that meet your needs, but they're borrowed instances, right? I mean, it's essentially AWS has an inventory of nodes that they have at their arsenal, and if it's not being used, they'll let you quote unquote lend it for your particular job. But when somebody asks for it, and they're paying their on-demand prices, AWS can take that away from you, right? And so I've seen clusters just go all completely away, and the whole job is completely lost, and it has to be run again because, hey, while it's great that we're using spot instances, you do need to be mindful of making sure that you are using it in the right scenarios. And so, all of these things can negatively impact your EMR experience to the point where you aren't getting the ultimate ROI for your particular environments. So now let's talk about what we can do in terms of what are the best practices for effectively tuning your EMR environment. And so how we're going to do this, we're going to use a data-driven approach to tune EMR for effective performance and cost. How are we going to do that? Well, I'm going to go ahead and show you a demo. And so of course, again, live. All my sessions logged out here, but it's not a problem.
Murphy's Law.
Yes, exactly. They know that I'm doing a demo, and this is what happens. But okay, so we'll start off by just overall talking about like just visibility into all of your jobs that are happening within your EMR environment. And so what I'm showing you here is Unravel as a tool. Real quickly, just from an installation perspective, we install within either your VPC. We also have a SaaS offering as well. And we're just collecting information about your jobs. And so I'm going to show you a couple of screens here on some of the things that we collect, both from an observability standpoint, but then also some added features in terms of proactiveness and insights and recommendations that we can provide, not just from your jobs, but then also from the infrastructure itself, like your clusters. And so I thought it would be best to start off here in this job view. And so what you're looking at right now is these are all a number of jobs that have been submitted in a particular environment. And the one thing that you'll find out here is that it doesn't matter if it's a persistent cluster or if it's a transient cluster, we are collecting all this information from a historical standpoint, right? So if you do need to identify trends, as your data pipelines are running and you want to understand, hey, how are data volumes growing? We have that information. If you want to understand, why did my job fail last week, but my cluster has terminated at that point, we're collecting that information. So from an observability standpoint, being able to have this information is actually really, really critical to making sure that your folks that are creating jobs are writing it in an effective way. And so what I'd like to do here is actually start off by showing some specific examples. So we're going to dive into some of these jobs here, but I'm going to go ahead and just do a little shortcut here. So we do have some analysis that's built into Unravel itself, and we can actually flag for specific events. And so I'll go through a couple here. So this task queue event, if I go ahead and just select just a random job here in my environments here, just from an observability standpoint, again, I just wanted to, for folks that really want to get into the weeds and really understand, how the resources are used on the particular jobs, you have a lot of these tools here, or these tabs here. So resources, what was the program that was running, the logs that might have been spun up. And so if there was any errors, we can really get in and really understand what, how this job ran, what were some of the bottlenecks, so on and so forth. But we don't stop there. We also, not only do we show, the folks what they need to know about their particular job, we do have some intelligence built in. And so here's an example where we do an analysis, and the way I like to call it is, you've got an expert in the box that's going to go and look at the cluster and say like, hey, look, in this particular job, here's some things that we could have done to essentially increase app resource or cost efficiency, right? So here in this particular example, we noticed, hey, there was a lot of shuffle stage with load imbalance detected. So this is your, common data skew issue, right? And so I won't go into the weeds of data skew, but when you're looking for making sure that you're using your allocated resources that you paid for effectively, you want to make sure that everybody is in a more balanced state. And so in this particular instance, we can see that there's some load imbalance detected. And so, we show, not only do we point it out in terms of like the stage and the task, but then more importantly, we go ahead and give you some, some insights into, hey, consider using additional keys or salting technique to distribute the data evenly across tasks here. And so again, this becomes a lifesaver for a lot of folks that, and this is a Spark example, but if they need to understand why, how can I make this application better, they don't have to go through the normal, trial approach where I'm just going to go try a couple of things, deploy it, run it, and then, rinse and repeat. You can take away all those steps and actually get that proactive analysis from within the tool itself. So that's an example of the, a skew event. We can also look at, maybe I'll just do just another example here. Maybe I want to understand, I think this is a contended driver event. So like, here's a recommendation for, looking at this is making your application faster. And so, hey, it looks like there's a lot of work that's actually being done on the driver, right? And so for folks that are looking for like, hey, I don't understand why, I'm not getting the performance that I need, here's one insight that we can provide to say like, hey, it looks like everything's mostly being done on the driver. You should actually visit your code to determine which app is spending so much time on the driver, right? On the flip side, for folks that maybe are looking for, or are the product managers, or maybe they are the managers of a development team, this becomes also very useful because now you have a way for a tool to proactively tell you, hey, where are some of the inefficient jobs? And, let's cut to the chase. You don't have to manually QA it yourself. Here's some insights that we provide so that way we can make sure on the job level, we are writing quality code to maximize the resources that are used, not over allocate resources that we don't need, and ultimately just speed up just the mean time to resolution for your jobs that might have run slow or have failed itself. All right. Okay, this one didn't time out, so that's good. So the next thing I wanted to do is give you some more insights in terms of like what we can do for providing recommendations on the type of EC2 instances that might actually work for your particular workload. Or even more importantly, if I wanted to have this as a persistent cluster, what could I use in terms of like auto scaling, and what are some of the insights that we can glean from a tool like Unravel? And so this report that you're seeing right now is, it gives us the ability to essentially look at all the jobs that are running in your EMR environments. And it gives you a couple of options, right? So maybe I'm interested in my Spark jobs across all of my clusters. And at first I may want to get a heat map view here. And so let me go ahead and select this page here. And so now I can start looking and saying, okay, it looks like Monday and Tuesday, not super heavy. Looks like I'm doing a ton of work on Tuesday, Wednesday, and Thursday, and parts of Friday. And it looks pretty consistent, right? So I've got a couple of potential options now. One, something to keep in mind, this is based on actual data usage. And so if I wanted to, this could be a good candidate for auto scaling, right? So Monday, light load, Tuesday, scale up, scale back down on Friday, right? Or this could be, if this is just one consistent, very, very long running job, this could be a transient cluster where, maybe I'm not using this. I offload some of these lighter load jobs to another cluster, and then it only, I can spin up a transient cluster that could be even beefier, and maybe even take some of the downtime or how long this particular job.
Uh-oh. I think we are there again. Oh, right in the middle of the demo too. All right, well.
All right, can you hear me now?
Yes.
Okay. Sorry guys, I'm just having massive connection problems today. Okay, can you still see my screen, Diana?
Yes, I can.
Okay, perfect. All right, so where I last left off is just identifying just patterns based on actual usage, where we can start formulating what could this potentially look like if, could this be a transient cluster? Can this be a auto scaling cluster? And so I have the ability to select any type of workloads here and start getting that visibility. Now, that's step one. Step two, now that we have got this information, let's start getting interesting in terms of some recommendations that can be provided from a tool like Unravel. And so here, what you're seeing here is, based on what I've selected here on the right-hand side here, I can go and understand hey, what are some of the instance types that might make sense for this particular workload? Now, keep in mind, this could be something, if this workload is compute intensive, you're going to see our instance recommendations lean towards that. If it's memory intensive, you're going to see memory bound recommendations or instances of recommendations. Not only that, but we're going to tell you the number of instances. So for your master node 1, for your worker, your core nodes, you're going to have 13. We also provide estimated costs. So if you are in the costing stage and you really want to understand what this is going to be towards the bottom line, we can give you that. And so again, very, very useful because this is based on actual usage. So we can really start right out the gate, make sure that we have our environments rightly sized, both for performance, but then also for cost, because we're not wanting to over allocate our instances. We also have an auto-scaling insight feature here, which again, it's looking at how the users are using the particular resources throughout the day. And based on that, we can actually provide a recommendation on auto-scaling schedule. And so that's what you're seeing here. And so right now we're looking at things grouped by the hour, and you can see that things go up and down depending on the time of day and what type of workloads are run there. So if I wanted to go and do an auto-scaling option, now I can start really doing an auto-scale that's going to be based on how, the usage patterns, all those particular jobs. We also provide some estimates in terms of what that potential savings can be. And so previously we were looking at $104 an hour. If we were to use auto-scaling, we can actually reduce 25% of the cost, right? And so, again, very, very useful for making sure that we're maximizing cost, or not maximizing cost, reducing cost. The other thing that this also I've seen a lot of customers use this for is, you start looking at this and you can start looking and understanding what's my minimum number of nodes that I can actually run in this particular cluster if this is going to be persistent and I'm going to be running auto-scale. So right now, everything you're seeing here is actually based on on-demand pricing. And so that's going to be the quote unquote list price that you're going to be paying. But, I've seen a lot of customers and customers do this pretty effectively, is actually set a minimum number of nodes in here. And I can see in my particular example here, 5 is the minimum, and then everything else scales up and down. And so if you are looking to further reduce this cost, you could actually look into using spot instances for this, because we're not asking for these instances to be running 24/7, but spot instances could be a great alternative for these scaling up and down instances that are greater than the minimum. And so, if you think about it, sometimes spot pricing can be up to 70% I've seen or even higher sometimes for specific nodes. And so, again, take advantage of this, because not only can we use auto-scaling to make sure that we're matching to the resource consumption of the particular workloads, but then we can also even further defray the $77 cost by leveraging some things like spot instances. So again, very, very powerful insights with a tool like Unravel that's really just data-driven and giving you the insights that you need so that you can make the ultimate decisions on what you need to do in your particular environment. All right, I've got 2 more screens I wanted to show you guys, but of course, I got timed out. So I'm going to load them back in here. And so the second to last screen I wanted to show you guys here is, zooming back out into your existing EMR estate today. It's always good to know, hey, where is my cost going? Who's spending most of the cost, or most of my spend in my AWS account? And so while there's while you can do some of this stuff, if you created some custom reporting, we have this stuff out of the box, right? And so we have the ability to look at things, and we can pull in tags from within AWS, and we can start looking at things such as okay, I've got a tag EMR release. How many clusters are actually being spun up? So this could be very, very beneficial for folks that are using job clusters and they want to know where all the spend is going. And so not only can we break it down by, grouping by, but in this case, this EMR release tag, but now we can actually get even further granular in terms of what was that in my EC2 spend? What was that in my EMR cost? If there is any EBS, how much was that costing? What's the average cost, percentage, total cost? All this stuff becomes very, very useful because, hey, maybe I didn't realize that in this particular example, EMR 620 was, taking up most of my spend here as opposed to some of the other, actually, let me go ahead and sort this. Yes, EMR 620 is where most of my spend is going in the last few days here. And so, those are valuable insights to just kind of understand, hey, who's actually spending up most of my resources? We can even take this a step further. So if I go and scroll down here, again, this is a more of a UI-based approach. So if I really just kind of want to have a visualization of where my spend is going, I can get that as well. Actually, it looks like, based on what I'm seeing here, from an average cost perspective, my EMR 5270 clusters are actually spending slightly more than my EMR 5260 clusters. But again, very, very good visualizations in terms of tracking how, from a visibility perspective, where my money is going. We can take this even further. So if I go and say, I'll go back to my EMR 620, hey, what was going on? Why is this particular tag, costing me, so much money, right? I can go in and start getting into the specific clusters, right? Again, these are terminated clusters, right? They don't exist anymore, but we are keeping track of that. And so from a visibility, observability standpoint, we can start understanding, okay, it looks like this particular cluster cost me overall $172. I could even drill into the jobs itself and really just understand, okay, this one doesn't have any data here, but, just really understand just from a historical standpoint, like, what were the jobs that were actually run? And, and so I can further start troubleshooting that from that standpoint. So all very useful features from a visibility standpoint, and we can get that from a tool like Unravel. I'm going to go back to the EMR. Yeah, there we go. Let me go ahead and just refresh this. And so that's more from a visibility standpoint from your EMR environments. But let's go ahead and click on this cluster insights next. And so this cluster insights, think of this as like, we've kind of established on the job level that, and also on a workload fit level, that we do provide some insights and recommendations. We also have those insights and recommendations based on looking at specific tags and seeing if there are any recommendations, right? And so here, what I'm about to show you here is I'm going to say, hey, I want to know if there's any insights that you can give me in the last 90 days on any cluster that was tagged with, in this case, a fill low utilized 30 tag. And so I can go ahead and click apply. It's going to go and look at all of the clusters that have this particular tag, and it's going to provide recommendations, right? And so here's an example where it's going to say, based on all the clusters, so all these job clusters, we could have some additional savings here, right? So this is a dev cluster, so the savings are a little minimal here, but the core value is the same, right? Look at everything that's there, and if there's things that we can do in terms of providing recommendations on instance types, which in this particular case, where we're actually providing a specific instance recommendation, what is that estimated cost savings, right? This is my development environment, but let's just say this is my production environment. And each time I spin up a cluster, these clusters are costing me thousands to tens of thousands of dollars every time that they run. This ends up actually being very, very beneficial. So that way I can go and say, hey, out of all the job clusters, the way that things are trending, it looks like I'm picking instances that are over allocated. Let me go ahead and, select a particular instance that's matched more closely to that particular workload. And so we can start defraying some costs from there. So hopefully this gives you folks, some valuable insights in the fact that, not only can we provide overall observability of your EMR jobs, both from a historical standpoint, both from a running standpoint, we also have this insights and recommendations to proactively make sure that you are getting the most from a performance standpoint and reducing your costs. So I'm going to go back to my slides here. And so just real quickly, just from a summary standpoint, guys, really everything that we've gone through, both from my slides and from my demo, is, really reducing the mean time to resolution for your clusters with better observability, like a tool like Unravel, right? If we can go and really speed up the process of understanding where the bottlenecks are from our jobs, where most of the spend is going, that's going to be very good for you to make the best informed business decisions for your EMR clusters. We also highlighted ways to take advantage of cloud-native features to first reduce cost, and so auto-scaling, again, based on actual usage, so that way we're not, we're actually reducing our resources on a needed basis based on actual usage. It's going to be very beneficial. Leveraging spot instances where it makes sense. So again, knowing where my minimum number of nodes, that could be my on-demand pricing. And then anything else that's very variable from that standpoint, that could be a good instance for spot instances. So do take advantage of some of the discounts that AWS provides in your EMR environments. And then maximizing performance. So making sure from a code quality perspective, hey, what are some proactive insights and recommendations? Unravel provides that for you. So you don't have to go and try to figure this out yourself. And ultimately, consider Unravel as the expert in the box, so to speak, for your development team. And then last but not least, making sure that you have the instance type selected for your transient clusters, again, based on actual usage. So that way I can go ahead and pick my memory intensive instances for my, memory intensive jobs and vice versa for my compute, and really take advantage of the fact that you have lots of instance types that are, very, very beneficial for the types of workloads that you're running. So if you are ready to take the next step, we do have a SaaS trial that you can go ahead and sign up here on this link here. Easy enough, unraveldata.com/SaaS free trial. And so for folks that would like to try this, try this tech within your environment, within your cluster today, we do have this option for you as well.
Hey, Chris, wait,
yes.
before you end. And so let me just put sort of us back on screen for just a moment, if I could.
Sure, definitely. 1 second.
Okay. So actually, I was going to say that we had one particular question related to the trial, which you just answered.
Okay.
So yeah, so someone didn't know that we had one. So thank you for answering that question. Another question was, how long does the tool have to run before it provides insights?
Great question. So we will, the deployment process is actually really easy. So that'll take maybe an hour or two at most to install. At that point, we start indexing, monitoring the jobs from within your EMR cluster. You can start getting insights for your jobs, right when Unravel is installed, but generally we'll recommend having it run for a few days. It's what we call our hydration period. So that way we can start getting more insights, more meaningful reports. But yes, I think, generally speaking, I would give it a couple of days for us to, really get some good understanding of the overall environment, and we can start providing even more meaningful insights and recommendations.
Excellent, thank you. And then there's one more. Okay, how would I connect my EMR to Unravel?
Yes, so we've got that SaaS approach that I had mentioned previously. And so the way that the SaaS approach works is you essentially would be providing it's really just a jar file that you would add to your EMR clusters via, if you're familiar with EMR deployments, there's a bootstrap action, which essentially means call the script when you're spinning up new instances. And then you just send that data over to the Unravel SaaS version. Encrypted. The only data that we're collecting is literally just diagnostics information, right? So like how long did things run? What was the resource consumption? What was actually asked versus allocated? all that good stuff. And that stuff becomes very valuable for us to show in an interface. And so we have that option. We also have a marketplace option. So for folks that SaaS may not be an option, we could do the same experience, but it would be from within your own VPC. And so you can look us up on the AWS marketplace from that standpoint.
Thank you. Well, that's the time we have today for the webinar. It's available instantly on demand on Bright Talk. So feel free to share this with your colleagues or peers via the same web address. If you're watching on demand and would like to ask a question, feel free to email us at hello@unraveldata.com. Let us know what you think about the session. Please rate this webinar and also let us know if there's other topics you'd like to hear about. And Chris, thank you for sharing your knowledge today and for being such a good sport with all the technical issues. And everyone, we look forward to seeing you at a future webinar. Thanks so much for your time.
Thanks, folks.
Take care.
Bye for now. Bye.
Bye.